Hello everyone, Ramya, Assistant Professor of CSC Department from Rogini College of Engineering and Technology, subject code CS3501, Compiler Design, Unit 5, Topic Principal Sources of Optimization. A transformation of a program is called local if can be performed by looking only at the statements in a basic block. Otherwise, it is called global. Many transformations can be performed at both the local and global levels. Local transformations are usually performed first. Function preserving transformation. There are a number of ways in which a compiler can improve a program without changing the function it computes. Function preserving transformations example common sub expression elimination, copy propagation, dead code elimination, constant folding. Common sub-expression elimination. An occurrence of an expression is called a common sub-expression if E was previously computed and the value of variables E in E have not changed since the previous computation. We can avoid recomputing the expression if we can use the previously computed value. For example, T1 equal to 4 into I, T2 equal to A of T1, T3 equal to 4 into J, T4 equal to 4 into I, T5 equal to N, T6 is equal to B of T4 plus T5. This is the given production of grammar. In this code, we have delete the common sub expression elimination. Here in T1 equal to 4 into I and T4 equal to 4 into I. This the both the statements are common expression. So we can eliminate one statement. So at the after the elimination we will get one set of grammar. That is T1 equal to 4 into I, T2 equal to A of T1, T3 equal to 4 into J, T5 equal to N, T6 is equal to B of T1 plus T5. The common sub expression T4 equal to 4 into I is eliminated as its computation is already in T1 and the value of I is not being changed from definition to use. Copy propagation assignments of the form F equal to G called copy statements or copies for short. The idea behind the copy propagation transformation is to use G for F whenever possible after the copy statement F equal to G. Copy propagation means use of one variable instead of another. This may not appear to be an improvement, but as we shall see, it gives us an opportunity to eliminate x. Example x is equal to pi, etc. Equal to x into r into r. The optimization using copy propagation can be done as a equal to pi into r. Here the variable x is eliminated. Dead code elimination. A variable is live at a point in a program if its value can be accessed subsequently, otherwise it is dead at that point. A related idea is dead or useless code, statements that compute values that never get used. While the programmer is unlikely to introduce any dead code intentionally, it may appear as the result of previous transformations. For example, I equal to 0 if of I equal to 1 open curly bracket, A equal to B plus 5 close curly bracket. Here if statement is dead code because this condition will never get satisfied. Constant folding, deducing at compile time that the value of an expression is a constant and use the constant instead is known as constant folding. One advantage of copy propagation is that it often turns the copy statement into dead code. For example, A equal to 3.14157 divided by 2 can be replaced by A equal to 1.50, thereby eliminating a division operation. Loop optimization. In loops, especially in the inner loops, programs tend to spend the bulk of their time. The running time of a program may be improved if the number of instructions in an inner loop is decreased, even if we increase the amount of code outside that loop. Three techniques are important for loop optimization: code motion, which moves code outside a loop; induction variable elimination, which we apply to replace variables from inner loop; reduction in strength, which replaces an expensive operation by a cheaper one, such as a multiplication by an addition. Code motion. An important modification that decreases the amount of code in a loop is code motion. This transformation takes an expression that yields the same result independent of the number of times a loop is executed or a loop invariant computation and places the expression before the loop. Note that the notation before the loop assumes the existence of an entry for the loop. Reduction in strength. Reduction in strength replaces expensive operations by equivalent cheaper ones on the target machine. Certain machine instructions are considerably cheaper than others and can often be used as special cases of more expensive operators. For example, x square is invariably cheaper to implement as x into x. than as a call to be an exponential rotation. Fixed point multiplication or division by a power of 2 is cheaper to implement as a shift. Thank you.